Okay, hello. Oh,
hello.
Hi, everybody. I hope we are back on session now. I believe so, at least. This is Stefano Borgo. I'm chairing this session, and we have 3 speakers here. I will present them shortly. Let me remind you the purpose of this session. In Ontology Commons, as Nadia was presenting this morning, we are in charge of developing or setting up the main structure, if you want, of network of ontology. We call it ontology ecosystems. And it is quite complicated because it takes what we know from research experiences, so the distinction between top level, middle level, and domain level ontologies. But then it has to build a system out of this, which means to put them together, make these ontologies to actually interact with each other, which is definitely not simple. We know of some cases, there are some experiences, but nothing at the level that we want to achieve. So for this reason, in this session, we focus on how to actually connect these kind of ontologies vertically from the top level to the bottom level and horizontally. We know from the literature that there are different ways to connect ontologies depending on what you're looking at. And since ontologies are complex systems, formal, logical, conceptual, the links can be of different nature. So that's why we gather 3 experts here, Jérôme Euzenat, Mossakowski, and Claudio Masolo, to talk about the different links and possibly to tell us how they can be used. So this is essentially the introduction to the session. So I will go quickly through this. Okay, to the organization. So you are recorded. Your mic is off, but you can always write on the chat for questions. I will let the 3 speakers to do their presentations, and unless there is some clarification, technical clarification on the spot, I would prefer if you hold all your questions to the second part of this section in order to collect all the questions and suggestions and viewpoints and have a common discussion. You can always raise your hand if you want to interrupt for some urgent question clarification. I told you already what the purpose is. The objectives are to present the different kind of links, to clarify the purposes of those links, and then to discuss how to build this network of ontologies using the links we have in the literature. Jérôme, probably you know Jérôme Euzenat for his work on ontology matching. It's probably it must be one of the person that actually decided what that term means, and his book with that title is let's say the master reading work for everybody in that domain. He's at the INRIA and the Université of Grenoble, Alpes in France. He's interested in different formalization, interaction of knowledge, especially in the same domain. He's now leading the OMEX, is that correct? OMEX team. They are working on cultural evolution techniques, always related to knowledge, of course. And I will introduce the other speakers before they started their talk. So Mossakowski and Claudio Masolo. And the discussion point, I will bring them back once we are done with the presentations. So at this point, I will stop my presentation and ask Jérôme to share his set of slides?
Yes. I know I see this. Okay. Okay, thank you for the introduction. I am, the slide will come. So I'm Jérôme Euzenat, and I will present you a very general and very fast introduction to ontology matching and alignment. And this is also joint work with Pavel Fajko from Trento. So the goal of alignment and the goal of ontology matching is to reduce heterogeneity between ontologies, and this heterogeneity can come from the fact that they use different languages. We won't address this here because there are specific techniques for doing that, and maybe it will be more a topic for Till Mossakowski's presentation. People may use different terminology, just like because they use different natural language, or maybe they use different sub-languages, and so they don't use the same term for naming the same thing. But maybe they don't model exactly the same thing, or actually they don't model them the same way. For example, some may represent as a class something which is represented from the other for the other as instances. And finally, there may be for two ontologies different scope. Of course, they don't necessarily describe the same thing, and some may have a wide scope and some a very narrow scope. And also the same granularity, some may be very deep and very precise, and some may be very general. So to give you an example here, you can imagine that on the left-hand side, you've got an example of an ontology for someone who's selling cultural products. So it sells books, DVDs, CDs. So this is an old example, obviously, now. And on the right-hand side, you can think of the ontology which is used by a librarian. And this librarian will have to buy books, so they've got to both communicate. You can see that on the side of the librarian is more interested into the category of content of the books rather than their forms. And also that this is only about books, while on the other side there are other mediums to be considered. This heterogeneity extends to the attributes which are used to describe objects. There are common attributes like authors, title, but there are for example, a librarian is not necessarily interested into the number of sales and the price of the item. So it's interesting, but that's maybe not its main concern. And these attributes may have a variety of values, so that you can see here that, for example, the creator will be a person on one side, and the author will be a writer on the right-hand side. And so there are obviously a relation between these items, but they are not explicit. So the goal, so there is a last thing, that these ontologies may be populated. So here you've got two examples of books. So there are books on the left-hand side, but on the right-hand side, there are literature books and autobiographies. So they don't really correspond in their description because of these two ontologies. So the goal of ontology matching is to build an alignment, and this is what you see appeared in blue here. And it tells you that a product is more general than volume, which is equivalent to a book, which is more general than an essay and or literature volume. So you can have this kind of relation between classes like here, but you can have them between attributes. For example, here it tells you that the creator is more general than an author, that the DOI is equivalent to an ISBN, even it's not necessarily true, that person are included in human, and that cells have a relation with title, which is very strange in this slide. You may have also more elaborate alignments. For example, on the right-hand side, you've got the notion of an autobiography, while on the left-hand side, you only have books described by their authors, their topic, their sales, their price, etc. However, if you have a more expressive language for expressing relations, then that you will find in these alignments, then you can express that an autobiography is equivalent to a book whose author is a topic. Okay, that's quite a correct description of this. So the more precise it is an ontology, the less you will need such kind of elaborated language. But if it's not precise, it may be useful at some point. Okay, so for being really fast, what I called these blue arrows are what I call the correspondences, and they relate two entities of two ontologies, but these entities may be very heterogeneous. There may be expression in or expressive languages, there may be classes, there may be instances, there may be a variety of things. So you can connect entities from heterogeneous languages. And there is a relation between this entity, which can be the equivalence, generality, disjointness, etc. And an alignment will be simply be a set of such correspondences between the same pair of ontologies. So the process for addressing this heterogeneity is to start with two ontologies, to apply an algorithm that we call the matcher, which can be relatively complex. It doesn't have to be one shot here, and to determine an alignment. And this alignment may be transformed into a mediator, a transformation, or something that will merge the ontologies so that the result of the ontologies and the alignment can be exploited. I will give an example of that, but I just want to emphasize that it is interesting to be able to represent the alignment independently, because you may find different alignment between the same ontologies with different matchers, and from the same alignment you may generate different things that you can need to use in this case. For example, if you've got a query which here requests the autobiography of Bertrand Russell on the right-hand side ontology and to return the ISBN, then with the alignment that we had before, you can use a mediator that will tell you that will transform this query so that it is possible to evaluate it with respect to the left-hand side ontology. And here, this is basically, you will look for a book which has a creator Y, which is the same as its topic, and was forenamed Bertrand Russell. And if you're able to transform back the DOI into an ISBN, then you are able to answer this question thanks to the alignment between the two ontologies and without thinking about the data. So there are plenty of application for this. Catalog integration, if you're selling product coming from various providers, schema and data integration and query answering in databases. If you have a relatively lightweight and autonomous system, they will be able to communicate together if they are able to align their ontology. So this can appear in peer-to-peer system, web services, agent communication. And you can also use it in data interlinking. When you are trying to find the links between objects, having an alignment may help you to do that. It will not do the whole job, but it may help you to do that. So, for example, you are interested in this in ontology engineering, so you may have several different top-level ontologies, not necessarily one, and you're able to build an alignment from that. From this ontology, you may have domain ontologies. They are usually related to their top-level ontology by direct reference, not really by alignment. Of course, you could try to build an alignment between these and the top-level ontology. This may be helpful, but usually you have built the ontology with respect to a domain ontology, and this can occur for both top-level ontologies as well. But now it is really interesting to have the first alignment between OT and O'T, because then you may take advantage of it in order to help you align the domain ontologies which are built on different top-level ontologies. And of course, after that, you may have some various application ontologies, and for the same reason, they will refer to the domain ontology that they take advantage of. But this reference plus the alignments that already exist may help you to build better alignment between these application ontologies, and then you will have this application able to talk, and this corresponds to the application I just mentioned before. Okay, On what basis can we do some ontology matching and in order to establish an alignment? For me, there are two main sources, which are the content of the ontology, that is what is inside of the ontologies, including instances populating this ontology. And there is a context, that is other external resources where this ontology is mentioned or which has been used by this ontology to annotate. Okay, so for example, you may imagine that you have annotated the element of a museum with several different ontologies, and because you have a lot of items in this museum, then this will help you align your ontologies themselves and maybe transfer data from another museum from one ontology to another. Okay, so I will don't go into detail of this because I will go into detail in the same thing. So of course you can look at the name similarity, and here you will see that title and authors appears in the ontology. So you may eventually think that they are the same. They may not be the same actually. In this case, that looks promising, but in some other case, of course, you've got homonymy, synonymy. But moreover, you also got that in the context of an ontology, a term is used for something else than what it is used in a dictionary. Of course, you can use a lexicon, which will help you to understand that book is more general than volume, that the person and human are basically the same thing. And because you have this, I will go a bit faster here.
Jérôme, yeah, because if you can go towards the end, please. Another minute is enough.
Another minute. So you see that basically I will go just through this, but by taking various cues about your ontologies, you're able to have a better sense of what are the correspondence between them. Okay, how well this approach works? There are a variety of systems. There is not one system which will solve all the problems and which is good for everything, but every year we evaluate these systems and in the OAI campaign, so you can see comment on that here. Now to conclude, the message that I gave is that, well, heterogeneity of ontologies is not a bug. This is perfectly natural that we've got different ontologies. And ontology matching is only part of the solution, but it is part of the solution. It could be based on various different techniques. But there remain quite some challenges ahead, and I guess there will. So some of them are mentioned here. And for example, reasoning with ontology and alignment, where everything is expressed in logic, is something that is not that easy, and that Mossakowski will consider now, I guess. Okay, and I will conclude there. Thank you,
Jérôme. Thank you. Very interested, and I loved your example. They give a real concrete case to discuss later on. And now is the time for Till. If you want to share your slides, Till is a professor of theoretical computer science at the University of Magdeburg. He's one of the leaders behind the DOL, the Distributed Ontology Language Standard, and he works in logic, semantics, neural symbolic integration, network, energy network integration today, Till?
Yeah, that's right. Yeah.
And now we move to something more logically based, right? Because he works on heads. I guess you are going to say something about this. So it's a different kind of approach to linking to ontology. Till, please.
Yeah, thanks for the introduction. Actually, it's not a different kinds of approach, but I will build on Jérôme's talk. While Jérôme has explained us how we kind of align on a syntactic level, I want to address the question how to give a semantics to those alignments, and also to integrate ontology along alignments. So you could reconcile different ontology into an integrated one. Maybe you don't want to use the integrated ontology, but what you can use it for is to check joint consistency whether your alignment really makes sense in a logical way. And I will also briefly address the topic how you can align across different ontology languages. So let's have a look at this simple example. It's in the notation of DOL, the distributed ontology language that Stefano just mentioned. I will mention this later on, what this exactly is. So here you have two very small ontologies in Manchester syntax. Of course, they could also be referenced by their URLs, but here we can have them in line. So we have a class person here. Alex is a person and a class child. Here we have a class human being, class male, subclass of human being, class employee. And then we align these two ontologies. We say that person is the same as human being, like Jérôme has presented it in his previous talk. Alex is a member of male, so Alex is an individual, male is a class here. And then we can say child is disjoint to employee. You could also use this bottom sign here, but here this is kind of input syntax, so we use a %. So the syntax actually follows the alignment API. So this is here done all by Jérôme, and we have adopted this in DOL. So now Jérôme, together with Antoine Zimmermann, has developed here in this paper 3 semantics for networks of alignments. So a network is a graph of ontologies and their alignments. And you can have a single domain semantics, global domain, and contextualized semantics. And if we have a network with simple semantics, that means all ontologies are interpreted over the same domain D. So that means a model for a network of aligned ontologies, so where you have a lot of ontologies indexed by some set and alignments between pairs of these ontologies. Of course, in Jérôme's diagrams of such networks, you have seen that not every ontology is related to every other ontology, but you could also leave the alignments empty then. So what you need there is you have a model for each ontology, but each of these models have the same domain, or that's a typo here, MI, of course. And then the symbol, so if we have a relation in the alignment, that symbol S is in relation R to symbol T, then the interpretation of S should be in the relation of the interpretation of T in the other ontology model. So that's basically the semantics of such networks. And the interesting thing is, okay, we can in DOL also have a notation for such networks. So we just take those two ontologies and the alignments and collect this into a network. And so basically, a model for such a network, you have a common domain, models for the ontologies over that domain such that all the alignments are satisfied. You can also say a model of a network corresponds to or is isomorphic. So such models are in 1-1 correspondence to models of a combined ontologies. So in DOL, you can just write, say, combine N. So then you get a combined ontology for the whole network. The semantics is given as a co-limit of this network. This is a notion of category theory that we don't need to detail here. We just look at the example here. That would be the combined ontology. Person and human being are kind of merged into one class. You have also a class employee and child. Now child is disjoint with employee. That comes from this alignment here, that things need to be disjoint. And male is subclass of person, human being as before. And now Alex has types person, human being, and male. And this Alex in male contributes to this here. So that's basically kind of a flattening of the combined ontologies and of the ontology, and therefore we can say that we have reconciled the two ontologies into an integrated one, even if we don't want to use this for further ontology development, we can just check joint consistency with standard reasoners in a semantically grounded way and maybe reveal some inconsistencies that either are caused by one of the ontologies in the alignments or by the alignments themselves. They could also be wrong. Okay, then there are, there is a way to compute the flattening. You can basically, here you have ontology O, you have ontology P, and then you can have a bridge ontology where you basically materialize the ontology alignment as an ontology, and then you can embed, or you have these kind of spans of morphisms here, where you kind of relate these ontologies with each other, and then you build a diagram, and then the flattening can be really seen as a co-limit, which is a standard construction that you combine everything into one. So you can also have different semantics. Integrated semantics means your ontologies can have models with different domains, but you embed them into your common universe. So you have these functions gamma, and then you have to use them before you check the alignment. And then for the combined ontology, you need to relativize all the concepts. That's the general construction. I illustrated it here with an example. So that's the same example in DOL as before, but now you have here assuming global domain. So you assume this integrated semantics with global domain. And now you get a different bridge ontology, and here is the integrated ontology. Now you have two top-level classes, thing O and thing P, and child is subclass of thing O, employee of thing P. So you kind of keep things more separate here. But of course, person and human being are still the same because the alignment says they are equal, and this is also a subclass of both thing O and thing P then here. And the rest stays basically the same as before. And the third semantics is contextualized. So that means here you don't have a global domain, but you have the individual domains are related with some relations, which are functional and injective. And the relations, the self relations are the identities, and you get converses and compositions here. And a model for such a network is then a model of the ontologies, that these kind of models, when translated via these relations, satisfy the alignments. So that's more complicated, but you don't need this global universe here. You can also have a bridge ontology for that. And with the running example here, now you say assuming contextualized, you get a different bridge ontology where now you have object properties for all these relations between the different domains. And then this relation also occurs here in the form of some existential restrictions. So here the mediation between the ontologies is a bit more complicated than when constructing the integrated ontology. Okay, now briefly coming to multi-logic alignments. We have a lot of languages in ontological modeling, like OWL, first order logic, higher order logic. Deutsche uses modal logic, for example. UML is also used. ER diagrams, SWIL, RIF, ORM, BPNN. So a lot of languages float around here. So there's a need for multi-logic alignments. Here is a syntax you can express this in DOL with. So here you have an OWL ontology, here castle, that's first order logic with subsorts. Equivalently, you can also use common logic with predicates. Then human being and male employee would be unary predicates here. That's kind of variance of notation. And one way of getting an alignment is that you first translate the ontology O to first order logic and then align in first order logic. We also have a paper where you can have truly heterogeneous alignments without the need to translate first, but this is not integrated in DOL yet, so here I can show you only this kind of translational variant. And then again, you can form a network and also check consistency of the integrated ontology. So this DOL language I use for this syntax here is an OMG standard for structures, ontologies, and much more. The syntax for alignment follows that of the alignment API. We have also invited Jérôme to some of these standardization meetings of DOL. You have a complete model, theoretic, formal semantics, so everything is semantically grounded. Here you see the central page where you can also get the DOL standard. And we also have a tool, so where you can try this online. Maybe I have a short time to demonstrate.
Maybe not until.
Maybe not. Okay. It's very quick, so you can just enter your ontology here. So this alignment.
Till we should close now. And
really get something here with a bridge ontology and look at the ontologies here. Okay, so the conclusion is the semantics of alignment provides the basis for computing integrated ontologies. We have also some representation theorems about this in this paper here. You can check consistency. You can compute modules if you have such a big integrated ontologies. For example, using the signature of the aligned symbols, then you can compute a module, which is a sub-ontology focusing on the relevant parts. Especially if you have upper ontologies, multi-logical alignments would be useful. And with DOL and heads, you have the tools to support all this.
Thank you, Till. So yes, I stand corrected. It's not a different approach, but it's building on top of what is already done. These approaches are not fighting one against the other. They are actually different ways to develop, or different perspectives to develop linking across ontologies. And now we are going to see a third one, which is more concentrated on conceptual alignment, so less on the problem of extracting the right individuals, or exactly the same individuals, even from different links, or different from just looking at how to integrate the logical theories behind the ontology. Now we are looking at what is the meaning of this stuff. Am I correctly connecting them independently of how the ontology is populated? And I hope this time I presented correctly. Now is the time for Claudio Masolo to tell me if I'm right. He's a researcher at the Laboratory of Applied Ontology in Trento. He's interested in knowledge engineering, conceptual modeling, and cognitive theories, especially in the ontological foundation of these research areas. And he's one of the main persons behind the Dolce ontology, and is a co-founder and has had different roles at the Association of Ontology and its applications that we learn about from Lovia this morning. Claudio, it's up to you.
Okay, thanks, Stefano. Then I will start to show some example of these semantic links between ontology that are relatively complex. And in order to do that, I will consider the example of time. Then just take into account the definition of what conceptual heterogeneity is given by Euzenat. And then conceptual heterogeneity stands for the differences modeling the same domain of interest. And then same, we will see, is not easy to define. And as I said, I will consider time, and what I will say is based on quite old stuff, basically developed during the 80s and the 90s, that has been where the ontology of time has been discussed a lot. And then there are different the main differences between ontology of times concern the kind of entities considered. Then there are ontologies that consider just instantaneous time, other that consider periods and then intervals, let's say, and other that just consider events and then temporal relation between events. And they differ also with respect to the primitive notion they consider. In some cases, for example, for the periods, some theories consider, for example, the primitive of precedence together with the partud, other just, in particular, the theory of Allen and Patayes, just one primitive, a primitive of myths, and how to reconcile, let's say, this different theory of time, if possible. And other consider also quite a different structure of the domain. For example, in some cases, the time is considered as linear. In other cases, as branching. In some cases, the entities of the domain are dense. In other, discrete. And here also the expressive power of the language is considered in order to express this ontology is important, because in some cases, some of these distinctions cannot be expressed by means of languages that are have a poor expressivity. Then the idea is if there are these differences, how is it possible at least to minimally guarantee a sort of interoperability between system-based and adopting, committing to different ontology of time? Then I will start to consider some examples just in order to understand how complex can be the links between these different ontologies. And one simple example is, let's suppose to have two ontologies that are both intended to be based on periods with exactly the same primitive relation, the precedence and partud relation. And let's suppose that just one ontology, but not the other one, contain an axiom, that is this one. I will not enter into the details of the definition, I have the slides, but just in order to... Then this axiom basically states that the periods are convex. Then this is, in some sense, a case of specialization. Then this ontology considers just convex periods, the other ones consider convex, also non-convex periods, then it's more general. Then in this case, it can be quite easy to have a link between those two. Let's now consider a little bit different case that is more complex then, and this can be just generate a genuine disagreement between these ontologies. Let's suppose we have two ontologies both based on instance and with a strict order, strict precedence relation. But the first one, the order is linear and dense, and the other one is branching and discrete. Okay. Then in this case, even though this ontology basically have a sort of same kind of entities, the same relation precedence, intuitively they are quite different, just because the axiom that regulate the precedence, that actually the two precedence relations are quite different, and probably also the domains are different. On the other side, it's possible, for example, in some cases, even though it seems that the ontologies are quite different, this is not always the case. Let's, for example, suppose to have two ontologies. The first one, both are based on convex periods, but the first one is based on the primitive of precedence and partud, and the second one, the primitive of myths, as I said. Okay, and then is it possible to basically have a link between these two ontologies, or they are really different ontologies? Well, one can, for example, start to say if inside of this ontology with two primitives of precedent and partud, it's possible to define myths. And actually, one can provide, for example, this definition. And vice versa, we can say if it is possible inside the ontology with just myths, if it is possible to define precedence and partud. And actually, you can consider these two definitions. Okay. One can then ask if it is possible, what axiom of the ontology based on myths are provable starting from the ontology based on precedent and partud when the definition of myths is considered. And vice versa, we can do the opposite. Then, in the case where basically all the axioms of myths are derivable from the definition and from the ontology. Then basically you have a sort of what in mathematics is called a definitional extension. Then basically the two ontologies are quite, even though basically the primitives are different, they are in some sense equivalent in the sense that one are definable in terms of the other ones. The interesting thing is that these definitions are not ontologically neutral. If you come back to this definition, then basically you underlying this definition, there are some ontological intuition, some ontological commitment in reducing one primitive of the other one. Then these definitions are part, let's say, of the ontological characterization of the primitives. And we can also generalize a little bit this approach when we consider theories that are based on different kind of entities. Then, for example, one based on instance and the other one based on periods. And then in this case, usually in mathematics, we consider mappings between mathematical structure. Then basically we consider also the domain explicitly, but there are other techniques. Then let's consider, for example, one ontology that is based on just instant and precedence, and the other one based on periods and precedence and parenthood. Then we can define a mapping between these two structures. And basically what says this mapping says that the set of periods, the periods are defined in terms of instance and all the precedence relation. Okay, then periods is just the set of non-empty convex subset of I of the instance, and then we can define basically the precedence relation and the parenthood relation that now applies to this set of non-empty set of non-empty convex subset of I, and then define these two. Then basically here we say that the periods x precedes the period y if all the points of x precedes every point in y. But you can have also different kind of links. For example, at least one point of x precedes all the points of y is another possibility to define precedence. And basically parenthood is just subset. Then generalize a little bit what I said before, taking into account the axioms inside the first ontology, the one based on instance, and my axiom for the precedent. Together with this mapping, okay, we can basically try to understand which property of precedence and parenthood are preserved inside the new ontology. And then see if the axioms that we consider in this ontology are preserved or not through this mapping. Also in this case, the mapping is important and make explicit some intuition you have about the link between points, instance, and periods. You can also have different kind of mappings. For example, instead of considering, as we have done here, non-empty convex subset of I, we can just consider couples of instance. Then basically periods are just couple of instance, and then define precedence and parenthood in this way. And in this case, you can also try to verify if the axioms works through the mappings or not. In this sense, you can see that this mapping is maybe less general than the other one, because basically it commits on the convexity of periods, while the other one can work also when periods are not convex. We can also look at the different direction, then starting from periods to build in instance of time. And then in this case, for example, instances are sort of filters of periods. Doesn't matter the technical construction, it's just that basically now instances are seen as a specific kind of sets of periods, and then also the precedence between these instances can be defined on the basis of the precedence between the periods you have through this discussion. Or you can also consider a different a different construction starting from, for example, the theory of periods based on myths. Okay. Or you can also consider the theory that are based on events, then basic convex events, then processes with two kind of relation, and build basically periods as equivalence classes of co-occurring events. And also this one is a quite complex kind of construction. Then at the end, okay, you have a sort of network ontology, as Steve said, also Jérôme said, okay, and you have this kind of mappings between all these different kind of ontology. Then first of all, these mapping are not ontologically neutral in the sense that they make explicit some intuition behind the instance, periods, and the primitives you consider inside the ontologies. And then not all the mappings make sense from an ontological perspective. They contribute in part, partially to ontological characterization of the nature of instance and the nature of relation. And then when you have loops, like in this case, then basically you can...
Claudio?
Yes, it's the last slide, just finish. Okay, when you start from instance, and then you are able to translate to prove all the axioms inside this other ontology, and vice versa, then it's very difficult to understand what are the basic entities. Temporal entities are instance or periods. Well, if there is a sort of equivalence, let's say, through these mappings. And that clear you can have a very quite different kind of mappings, or maybe you can also have some genuine disagreement between this ontology. And this is something that basically is relatively open how to treat this. What happens if this ontology really disagree? Is really that we cannot basically consider anything transfer of data from that commit to ontologies to another ontology, or maybe some partial data can be translated. And clearly, these kind of mappings are very important. Complex mapping are very important, especially at the top level, where you have a very basic and general notion that are, let's say, used on several other kind of domain or middle level ontologies. Okay, finished.
Thank you, Claudio. Thank you, everybody. Now, Jérôme, Till, you should come back on stage because we have the discussion session. And I will start from one question which is in the conversation here, the question answering. I believe it was set for Jérôme from the start, but I guess it's an open question for everybody. It says, is there a software tool that you would recommend for ontology alignment matching? I should add another thing here, just to keep the context of the discussion. We should keep in the background the fact that we are talking about an ontology ecosystem. So when we answer a question, we should look at that in that area. Are there, other than software tools that we can use for larger network systems? And then you choose how to answer, of course. Jérôme?
So with respect to the tools, so it depends what you exactly want to do with them. Okay, so if what you want to do is actually do matching, I would mention two tools that I know that are quite available and have good performance, which are LogMap and AML. But as I mentioned, it's worth looking at the OAI results and reports to have an idea of their performance, their capabilities, and to have links to these tools actually. If the goal is to kind of represent them and store them, I would mention the alignment API that I authored. or the tool that Till presented, but I can give the floor to Till about Heads and OntoHub that they created.
Yeah, in a sense, what I presented, DOL and Heads and also OntoHub are tools that are complementary to what Jérôme just mentioned, because what is this log map and AAML are basically if you want to compute the matchings. And with DOL and Heads, if you have already obtained your matchings and want to organize this into a network of alignments and want to reason about that logically, then you could use DOL and Heads. So these are kind of two different parts of the story which are complementary, I would say.
Okay, thank you. I remind people that if they want to ask a question, they can raise their hands or just write the question in the conversation tab. Now the point is the point I'm interested in is assume we have put together a set of ontologies, connecting them the best we could with the different types with a scene. Now we have to use this as a single system, and we want to reason with that. The reasoning might go through links of different types. Do we have any way to guarantee that what comes out is somehow reliable? Would you suggest restriction on the use of the links? Should we modularize the system? Somehow block the use of some links if other links are used? Do you have any experience of somebody that tried to do something like this? I know it's hard to answer.
Yeah, so I'm not sure if Jérôme doesn't want. I can answer something. So if you have a network of ontologies and alignments, of course, what you could do is to try to set up cooperative reasoners that do local reasoning in the ontologies and propagate their results through the alignments. But I'm not sure whether such a system exists. So the kind of more easy answer that I would offer is to use Heads to compute an integrated ontology and reason with that. And if you find problems there like inconsistency or unwanted consequences, then you need to kind of repair one of the ontologies or one of the alignments or both. Yeah. Then there's also confidence factors in the alignment API, so you could give different confidences. But I don't think that there is a kind of probabilistic reasoning tool that takes into account the confidences. But maybe, Jérôme, you can correct me if there is such a tool.
Tools, I would not say, but you can use them, for example, when you've got to repair. Mm-hmm. So the problem is actually not really that there not exist such tools, is that different tools will provide you with the same values between 0 and 1, which don't necessarily mean the same thing. So if you want to use them to repair, you need to take those who come from the same tools. There have been several attempts at building distributed reasoners. I would not pretend that they still worked. There was one design in Trento, I don't remember the name, in particular by Luciano Serafini. Mm-hmm. Another one by Antoine Zimmermann and Chan Leduc, and Chan Leduc is still maintaining it. But well, the expressiveness of the ontology is relatively low, because otherwise, if they want to have a complete reasoning, they have trouble to do that. And both were based on Tableau.
Well, the expressivity is actually. Oh, sorry, I have an echo here. Expressivity is an issue raised by Nicolas Figueiredo, I believe. He was asking. I believe that the question came out while Claudio was speaking. So I assume he refers to his presentation. He says, he asks, can such mapping be formalized in a computable way, for example, using OWL2? And this is, unfortunately, a question we can always answer positively. I don't know exactly the context. Claudio, if you want to add something, otherwise I'll ask Nicholas to come on stage and ask explicitly the question.
I mean, if he was referring to my presentation, okay, clearly there are some links that can be probably expressible by means of OWL, but other ones are much more complex. In some cases, for example, starting from periods to events, the construction is purely set theoretical, and also in some cases second order. Then the language is required for expressive links can in some cases need to have a quite complex, a quite high level of expressive power. Then this does not mean that maybe there you can have some approximation, like when you start from first order theory and you try to approximate it in OWL or ontology with lower expressivity, but this is not an easy task in general. Then
there are works on approximation of knowledge in lower languages. Actually, that's an area where every so often something new comes out. But I'm not sure there is a comprehensive way to approach this problem. I move to Wilfried, unless somebody else wants to add something. He's asking, how do you reflect on the ability of abstraction of different stakeholders, considering alignment techniques as they were presented? So I'm not really sure, maybe Wilfried wants to add something, but I believe abstraction here has to do more on the fact on the level of granularity of the ontology, or the different perspective the stakeholders may have on the same scenario or topic. Maybe if you want to add your interpretation and try to answer the question.
I'm not sure what abstraction means here, but if abstraction is just a generalization, let's say, then basically instead of doing link at very specific categories, you just concentrate on quite general categories. This, I think, can be done by linking this general category. If abstraction means something different, like aspect of granularity and this kind of stuff, this is something not only difficult from, at least as far as I know, not only difficult in order to link different ontologies, but also to express it inside a single ontology, okay? How inside a single ontology one can take into account granularities or different description that done a different level of granularities. This is something that is complex in general, and as far as I know, there are not clear definitive answer to or recommendation in order to do that. There are some old work, also Jérôme have done some work about granularities a long time ago, but then it really depends on what abstraction means here.
There is an addition by Wilfried on the chat. He says what he refers to are perspectives which might result in different abstraction of concepts. So that makes a little more clear the meaning. There is the fact that we might build ontologies on exactly the same field, but we have different roles, so we look at it in different ways, and so we focus on different concepts and come out with ontologies that do not necessarily talk to each other, at least apparently, even though they are about the same domain. That's a general question for ontologies, I would say. I don't know, maybe, no.
But if you take into account, for example, the example of time, that is in some sense quite a simple example. Okay, it's not. And then you say that there are really different perspectives, really different possibilities, and in some cases it's quite complex to link one with the other one. Then the same happens clearly in every domain. And then I don't. I mean, you can consider every ontology as a sort of ontological choices and formalized in some way as a perspective on one domain, even though one or same domain is difficult to be defined, and when you have a different, like for example in the case of time, same that you have the same domain, but in one case you represent as linear and the other one as branching, or in one case as dense and the other case as discrete. I'm not sure you can talk about the same domain in this case. Okay.
Well, from the point of view of the model, it might be the same domain. So I remember some years ago, there was a Luciano Serafini that Jérôme mentioned before, and Chiara Ghedini. They were working on the notion of wedding, and they said, okay, I can model as a concept. Other people might model as a relationship. And well, they are very different things, logically speaking. But they say, but they are convinced to model the same domain, and they just come from different perspectives. They make different ontological choices. I wonder, Till, do we have any logical technique to manage this kind of stuff? When I do have, as a user, I would say I'm talking about the same things, but as a logician, I would say, no, actually, you're doing very, it's a very different conceptualization.
No, I'm not sure. So if I understand Wilfried in the chat correctly, he says, I had in mind same domain, different viewpoints. So this reminds me of Jérôme's example with the book and volume. So these are different or product. Yeah, you have this example was, I think, already showing that you can deal with different abstraction levels if you just align them with kind of subclass relationships. If you are talking about the same domain, that was Wilfried's assumptions, then you avoid the complications that Claudio mentioned, and then it's fairly easy. But maybe I'm missing some complexity here.
My understanding, but he can say more. My understanding was domain is not the logical domain, the domain of quantification, but it's the domain where I work. So my application domain.
Yeah. Okay.
Yeah. Jérôme, do you want to add something?
No. This is what what I meant was indeed the domain of kind of application, precise general purpose ontology about a particular topic.
Okay. Thank you. Now I move to Arco Paul. How to tackle different level of interoperability, and he lists lexical, syntactic, semantic, and semiotic among ontologies at the same time. He's of course talking about our ecosystem that should be able to make ontologies to talk to each other, even though the connection might be at different levels, let's say. Do we have techniques? I should add always mature techniques to do something like this, and if we have them, what are the limitations, and what can we actually do up to now?
I am not sure that I really understand the question, because if you face several kind of heterogeneity at the same time, then I don't know how to answer, except that you will deal with it. If you have ontologies that use several terms, then you will treat them with some terminological techniques. Okay, but that doesn't mean that you will solve the problem. Okay, because maybe they have different terms, but also they are talking about the things for being used in different ways, and so there are semiotics or pragmatic issues that will come up. So I would say everything has to be taken together. Of course, there are some systems which only deal with some part of the work, but in principle they always try their best to match things that means the same. And how is meaning is defined at some semantic level or semiotic level or kind of other thing that you can imagine, then the system may be short to understand it, but it tries, I would say. I don't know. It's easy to take one by one, but it's necessary to take advantage of everything when this is needed. I don't know if it's a satisfactory answer to this question, but I'm not sure I can answer otherwise.
Maybe I can add, if you just take all the 3 talks that we have given, yeah, I think they covered all these levels somehow. So all what you need to do is integrate all the material in the talks, and I think that can be done.
That's good news. I like it. Do you have any experience of even at a small scale that this works?
No, the only thing that I tried is to use BioPortal. There are a lot of alignments in there, yeah. And I tried to kind of, and this is purely syntactic, yeah. Yeah, maybe also a bit of semiotics is in there, but clearly they have not considered whether this semantically makes sense. And I wanted to try to do some integrated reasoning, but at that time there was a problem that these ontologies had syntactic problems that we had to solve. So we are now working on that, and in the near future I want to redo the experiments. So yeah, but it was, yeah, there was a lot of unexpected syntax problems before we could check whether this semantically would make sense.
It would be interesting to do an experiment with the ontologies that we are developing in Ontology Commons in the manufacturing or material domain.
Yeah, sure.
But we can discuss about it. That could be quite interesting. I don't know if Jérôme and Claudio wants to add something on this. Okay, so I will move to the question from Hedy. Do you think that top-level ontologies and middle-level ontologies can play a role in facilitating matching of domains or application ontologies? And of course, being involved in Ontology Commons, he wants to be very practical. So he says, well, if yes, how? Just what you think. You don't have to defend it too much.
Yeah, personally, I think that the answer should be yes. In particular, it could be useful in providing a common ground. Okay, that is basically your middle level ontology are grounded on the same top level ontology, assuming that you use only one, and that your application ontology are also grounded on this middle level ontologies, and you can reduce things and constrain them far more easily, in principle. Now the devil may be in the detail, and then you can also put them into all of this, for example, into the tools described by Till, and try to do reasoning with your application ontologies based on their link to the middle level ontology and their own link to the top level ontologies, I would say.
But Jérôme, if I correctly understood one of your slides, the slide you presented, let's suppose you have two middle-level ontologies that are linked to two top-level ontologies. And there is a link, a mapping between these two top-level ontologies, but not a direct mapping between the middle-level ontology. If I correctly understood, this link between top-level ontologies can also help in order to find mappings between the middle-level ontologies that are linked to this top-level ontology, right?
Yes.
Okay.
Yes. Yes. Yeah.
Till, do you want to add something, or should I move?
No.
So I have a question that is always related to this ecosystem, which I'm struggling to understand. So assume now that we have some ontologies, and we built the links to connect them. The ontologies are quite different. They are different levels: top level, middle level, domain level, even application level. And they are, I would say, not stable. So one of the things that surprises me is that after 20 years of foundational ontologies, there is only Dolce, which is still the same, but every other ontology has gone through several changes, even complete restructuring. So even if a top-level ontology is not as stable as we thought in 20 or 30 years ago, how can we rely on the stability of the links across the ontologies? So the question is, okay, I built my ecosystem, I have all my connection on different types, I can maybe modularize it in order to make my reasoning correct, and then how do I test that my links are still holding a month later when something has changed? So what do you suggest to do in order to make sure that the system does not collapse? We can assume that every time some ontology is updated, the system is advised. But then we need to have a way to test, because the links are not made necessarily by the person that is updating the ontology. Somebody else may have put them there, and who knows how the links are going to change. Is there a way to test them, automatically update them, or do we have tools for this? I know it's a hard question.
It is possible to test if the change introduced an inconsistency which was not there before. This is possible. Okay. There's also another thing, which is basically that, for example, you have destroyed a concept which was there. Okay. And which was aligned with some other concept of some other ontology. So then you can react to the destruction of this concept, for example, by, if this was an equivalence, by putting a subfunction with a super concept of the previous one. So there are some ways to deal with the dynamics of this evolution. On the other direction is a bit different. Imagine that you are connected to a particular concept, and then this concept now has subconcepts, okay? And you knew that you were more general than this concept, so maybe you're more specific than this concept, so maybe you are equivalent to some new of these subconcepts. Maybe not, but maybe. So then you may have to match again, or to try to guess some compatibility things, etc. So this is a partial answer. It is possible to build tools, again, based on logic. It is possible to build tools based on some matching systems for trying to follow the changes, but it would be not necessarily semantically correct. But you can. It is possible to build such follow-up tools here.
Would be good, is it an option to have some kind of a test domain when you update an ontology? Do you have also to update how you populate that set of individuals? And that gives a list from the practical point of view of information retrieval, the possibility to say, okay, I'm correctly extracting the right individuals in the new version of the ontology, and the links do respect the new version of the ontology. I don't know, it's one way to build from the population of the ontology instead of from the conceptual alignment, let's say. Do you know anything in that sense?
The advantage of having populated ontology is that it is very easy to make it inconsistent. Right? It's easier to make it inconsistent, and so then you know that you've got something to do, I would say. Is there things made in this sense? So all the systems which are trying to do matching repair, indeed, in general, they are static. They have been made for repairing a matching which is there and which creates inconsistent or incoherence. Okay, we do some. Okay, what we do, the kind of experiment that we do in cultural knowledge evolution, and which is related to evolving both the ontology and the alignments now, is basically that, so this is the dynamic, is that the agents are using their ontologies and their alignments in order to communicate in some way. And sometimes it doesn't work. So they realize that there is an error somewhere, and they dynamically correct it. Okay, so it's a bit more related to what you say. Currently, we are experimenting only with static environment. That is, what is true in the environment at the beginning is still true at the end. Okay, so we don't the environment does not experience drastic changes, but we really would like to do this, basically making terrible change in the environment, having the appearance of a new kind of virus, or the disappearance of a kind of, I don't know what, even virus as well, and see how the knowledge of the agent will evolve, and what is it good or not with respect to these changes. So this could be used with your ecosystem as well, indeed. Now we've got to fix the detail, because at the moment we are mostly experimented how this kind of thing works, rather than providing solution to any problem.
I've just an idea that comes to my mind. Couldn't you use the static environment to build alignments between different versions of the same ontology, and then kind of try in this network of alignments that you get then, if you have, say, two new versions of your previously aligned ontologies, then you can align both the ontologies with each other and then with the new versions, and then you can try to kind of lift the previous alignment to the new version. That's similar to the kind of lifting of upper ontology alignments to mid-level ontologies.
Yeah, you can try to do this as well, yeah.
Interesting. Claudio, do you have anything to add here?
Well, the problem is that if you then this dynamic problem, I see it very difficult, because let's suppose you change an ontology evolves that is linked to another ontology evolves. Okay, now you can, as Jérôme said, try to test if still the link is consistent with this inversion or not. And if it is inconsistent, then you can say, okay, there is some problem here. Maybe it's the link, the mapping needs to be also changed or something like that, or you need to check if the ontology now is inconsistent, basically also intuitively from with the other. But even though still the system is consistent with this new version, I think that the mappings need to be taken into account, because maybe even though it is consistent now, it does not really make sense from a conceptual or intuitive perspective. Okay. Then, for example, if I move from just convex periods to everything, to any periods, convex or not convex, and the mapping was based just on a couple of periods, a couple of points, maybe it works, still works, I don't know, maybe still works, but it depends on the action we have in the new version of the ontology, if it is a quite poorly characterized ontology, you don't see the difference, but the link intuitively does not work anymore. Then it seems to me that in any case you need to recheck the links, and clearly all the automatic reasoning, check of consistency, and blah, blah, helps you in order to understand problems. But even though everything is okay, you still can have some conceptual or intuitive problems, just because the new ontology is changed and the link does not make sense in the ontological perspective, the conceptual perspective. Then this is quite problematic, especially if you do that at the top level, and then you have a lot of ontology linked to the top levels, and then you have used this top level ontology in order to, the mappings between top levels in order to determine, or at least to better specify the mapping between middle level ontologies. And then when you change one of the top level ontologies, basically you need to redo everything. Then this is a problem. I don't see how you can basically mitigate this problem. You can have some automatic tools in order to help you in order to individuate problems, but in general, it's very hard.
So the good news is that when we build the ecosystem, we are sure we provide a lot of work to ontologists for the future. Now I move on to a question from Emanuele Ghedini. It's more an observation than a question. He writes on the question answering tab, following EMO experience, Emanuele is one of the major persons behind the ongoing development of the EMO or top-level ontology. He says semiotic alignment is the most important heterogeneity to address. Terminological alignment is really a simple issue. If we drop the unnecessary assumption that only one single term is associated to an entity. I'm not really sure we do this. We make this assumption. Perhaps maybe in the semantic web community, this is more common. Perhaps you know better than me. What do you think about this comment?
Of course, I think also, as Jérôme said, the terminological alignment can be used in order to start to individuate possible mappings, but it is not that the maps are based only on terminology. Otherwise, then it is an input in order but are not enough. I think in general, if I correctly understand what Jérôme said. And semiotic alignment, I'm not sure to understand what a semiotic alignment is. Then I will not discuss this point in detail.
Till, Jérôme, do you want to add something? Or I can always ask Emanuele to say something.
Maybe semiotic alignment here means the problem that you have two ontologies that not only have different terminology for the same concepts, but they have really different concepts, and these concepts cannot be easily related because yeah, they are not well aligned with each other. That refers to Claudio's talk. Yeah, you have dense time and discrete time, or linear and branching time, and we have all these phenomena also in other ontologies, where you have different kinds of taxonomies that do not easily match. That you, yeah, for example, you have binary relations of parthood and ternary relations of parthood dependent on time, or things like that. And you have all kinds of these complex problems, and I don't see another way than just entering a detailed analysis, as Claudio did in his talk, for each such semiotic problem. Yeah. There's no general tool for this.
No, I forgot to say, I agree with you, Till. I forgot to say that this was an example with time, but we have very similar problems and more complex because of the dimension for space. We have different similar problems, for example, for theory of persistence, as you said, you need to have a part of the relation that is binary, or you need to add the temporal arguments, and how, if you have just a binary relation, it takes into account the fact that object changes, and then are you more three-dimensional or four-dimensional? There are a lot of discussion also at the philosophical level between these two different kind of view on how object persists through time. You have similar stuff, for example, about the different levels of reality, and then how you can basically ground some kind of entities on other simpler entities, if they are reducible or not, if there is a sort of emergence. Then there are clearly a lot of different view of very similar kind of problems, or domains, if you want to use this, and this can be quite difficult to and then, but I'm not sure that the word semiotic here is I will say that there are different perspectives. Okay, you can say this semiotic, and that is more semantic alignment than semiotic, if you want. But this semantic alignment it's true that underlies a different perspective, a different conception, also a different way of understanding, for example, how things persist through time.
Okay, thank you. I don't know if Jérôme wants to add something. Otherwise, we go.
Maybe yeah, semiotic may be also related to the way people use the terms, independently of the way they are defined. Okay, so this is somewhat related to what I called context-based matching, and so what is simple issue if you and
he's specifying.
Oh, did I wrote that? Come on.
Interpretation.
Yeah. Then yes, you've got to resort to how people take advantage of the concepts that are used, and try to match this. This is, I mean, what I mentioned before that we try to do in cultural knowledge evolution is this kind of thing on a certain scale. So the problem is that not everything is in the ontologies, and you've got to find the basis for matching outside of the ontologies. Of course, should be consistent with the ontology. But yes, to answer fully the question, I would say that basically there are ontologies which are very close or variation of each other, like Till mentioned just before. And then with the terminological matcher, you are able to rematch it relatively easily. And the further you go away, the most difficult it is. So you've got to pile up a number of techniques, and then you've got to resort about the way people use the ontology in order to really understand what they mean in this sense.
Thank you. Now we are closing, and I have a last question for you. So I just need a short answer. Assume we are building this ecosystem and we are solving at the best the way to build and maintain the links across the ontologies. So which one would be the problem that you would like to be solved from your point of view? So the topic is building an ecosystem that interacts with the ontologies, right? And we do with the links. And we have plenty of types of uses of this link. Okay, now assume we did it. Which one is the problem that you say, okay, yes, I wanted that one to be solved when I talk about linking ontologies? Just tell me which one is for you the problem you would love to be solved, if there is one.
I think the
So I'm not sure.
The last one that we
Go ahead.
discussed, to have better tools or a toolkit for actually solving these semiotic or interpretation-based interoperability problems. That would be cool, but that's also the most difficult problem, I think.
Jérôme?
Yes, for me that indeed it's useful for all problem of communication between entities, but there is something that I tend to say to make people think how difficult it is that how long do you think that it will take you in order to have total full understanding with your most significant other?
Thank you. Claudio?
No, for me, one interesting point is, especially if we consider the case of data that are basically connected to ontologies that are explained and let's say by means of ontology. What happens if this ecosystem, if we are, for example, also at the top level, but maybe also the middle level, when you have real differences, real inconsistent view on the domain, then does this mean that because there is inconsistencies, we cannot do anything about this data, or maybe we can, and I'm sure there are tools, I know also some of them, that try to, let's say, not propagate the inconsistency to the whole ontology, but just take into account some, and then how it is possible, at least partially, to access the data, even though encoded by different ontologies, even though globally the two ontologies are inconsistent. Then this is something that for me is interesting, even if I don't have a lot of competencies in order to solve the problem. It's just a question.
Okay, thank you all for the discussion and the people for the questions, and I wish you to have your top problem solved in the future, and hopefully Onto Commons will help to move into that direction. Thank you, Jérôme, Till, and Claudio. It has been a pleasure. And with this, we close our session, and we have the lunch break.
Thank you for sharing.
Ciao, thank you.
Ciao, bye-bye.
Thank you all. We will now have a lunch break and we will be back for the next session at 1:15.